Hey you guys, welcome back to another video, and today we're going to go over a proof that was from the past regions of June 2024. Alright, let's begin. So I've went ahead and written down our givens right here. Let's analyze. So AB is perpendicular to BC, which we have marked up here. DE is perpendicular to EF, which we have marked up here as well. We also see that AE is congruent to DB, which is right here, which I've marked up. Next up, we have AC is parallel to FD. Now we can begin our proof. Alright, so number 2. First of all, since AB and BC are perpendicular, to create a 90-degree angle. Likewise with segment DE and segment EF. So we find that the measure of angle B is equal to 90, and the measure of angle E is also equal to 90. And we are able to determine it because of the definition of particular lines. Next up, now because of this, by the transitive property, we can say that the measure of B is equal to the measure of E. So by the transitive property, since as you can see, they're both equal to 90, making them equal. Next up, we have 4. Now we can say that angle B is congruent to angle E. Let me just number this real quick. 3, or number 4. Number 4, we can say by the definition of congruent angles. Congruent angles. Let's move this over a bit. Alright. Now we have an angle. Now let's try and find a side to prove the congruence. Alright, number 5. Alright, so we are given that AE. We are given that AE is congruent to BD. We also see that both triangles, they share the side EB. So let's go ahead and write EB is congruent to EB. This is possible by the flexive property. Alright, so now we can set up an equation. We find that segment AE plus segment EB is equal to AB, while segment DB plus EB is equal to DE. And when you guys write these segments, right, make sure you put a line above the segments to tell them that there's a segment, which I'm going to do right now, as well as in my given. Alright, now I'll label it number 6. Now we were able to do number 6 because of the addition postulate of segments. Addition postulate of segments. Alright, up to number 7. Now, number 7. Now we can substitute AE by DB. As in our given, we found that it tells us that AE is congruent to DB. So now let's substitute it in. DB plus EB is equal to AB. Now, what you guys will notice is that DB plus EB is equal to AB, right? It is also equal to DE. So now, because of the transitive property, we are able to find that segment AB is congruent to segment DE. Actually, no, you can't just say it right away. We have to say that segment AB is congruent to DE by the oh, sorry guys. How am I spelling this wrong? Okay. Property. Alright. So now, segment A. Back to what we were saying. AB is equal to DE due to the transitive property. Alright? Property. Next up, now we can say that segment AB is congruent to segment DE. Segment DE. This is possible by definition of congruent segments. So let's go back to our triangles and let me show you something. Alright, so we have a congruent angle and we have a congruent side. So we can solve this by either the AAS or the ASA. Now, let's solve it by the ASA. Alright? So, first, let's go back to our given. Our given tells us that AC is parallel to FD. Now, what this means is that AD is a transversal. AD is a transversal, meaning that angle A and angle D are congruent. Angle D and angle A congruent. Let's write that down. And D are congruent. And their relationships are alternate interior angles, and our reason is by the alternate interior angles theorem. So now we've completed the ASA. Finally, we can prove it. Triangle ABC is congruent to triangle DEF. By the ASA triangle congruence theorem. I hope you guys enjoyed the video, and if you guys want to learn more, hop on to another video by Professor Devin. He will also be going over proofs.